date. But you can go to his channel if you want to see the whole thing.
Let me see if I can open up my first question. This is actually a question that was sent to me by James Delingpole, who writes for The Spectator and Breitbart, among other things. And
yeah, doing well.
He's I think fairly well known as a prominent climate change skeptic. And he asked this question. He said, does Pottola even understand the skeptical position? And if he does, what's his defense?
My basic answer to Delingpole would be, what is the critic's position? Because the critic's position is different according to who you talk to. I mean, for example, you take the position, or at least you seem to agree with the position of Willie Soon, since you reprinted his graph in your video. And I'm not sure if he knew it was his graph, but it was a graph from his 2005 paper, showing that the sun is increasing in power. There's more heat, more solar output.
Because the truth is that 2018, when you look at longer time frames, is not that much of an outlier. In fact, ice levels seem to rise and fall with the temperature of the sun. Funny that, isn't it? So question 2 is this: why does Arctic temperature, which is what all this recent fuss is about, correlate pretty much 1-to-1 with sun temperature?
Now that's his position. He's a critic, or what you would call a skeptic. On the other hand, there are a lot of people like Anthony Watts, who runs What's Up With That, who says no, the sun is decreasing. So what is the position? Some people say that CO2 has no effect on global temperature. Some say it has a small effect on global temperature. Some people like John Coleman say that CO2 is too small to be effective because it's only 0.03% and a teeny weeny amount. And yet someone like Christopher Monckton says that CO2 is plant food and it's absolutely essential for the planet and has a huge effect. So there's no skeptic position. I've read something called the Skeptic's Manual, and I also read I saw Molyneux's video on the skeptic's position in 12 minutes. But that bears no relation to what a lot of skeptics out there are saying. This is why I say they're critics rather than skeptics.
Just one thing. A lot of people in the chat are asking me to ask you to turn your camera off to improve your audio.
Okay, sure. So I'll show you that. Willie Soon thing, because I have that. Okay, this was on your video, and you were using this as an example, as Willie Soon did, that Arctic temperatures are following solar output, or total solar irradiance. You can actually see the scale on the left-hand side is in watts per square meter, which is how TSI is standardly done. But he shows it increasing over the last 40 years, very clearly. You can see, if you look at the timescale at the bottom, the last 40 years shows an increase. And yet, Anthony Watts, just about every other so-called skeptic or critic of climate science would say, no, that's wrong, it's been increasing, and in fact, decreasing. And in fact, it has been decreasing. That's very clear because they can take measurements from satellites of the output of the sun directly, and it shows a very clear increase. Now, I'll give you another graph which shows that. First of all, here's the PMOD graph from the Max Planck Institute. I'll put that up on the screen. Okay, there it is. Now, this is the actual measurement of total solar irradiance. This is a satellite which measures the output of the sun. So you can see quite clearly from that it's going down. Now, this is not controversial. As I said, this is not just something that is a debate between scientists and critics. I'm going to show you another graph here. This is from Climate for You. And Climate for You is not by any means a site that is sympathetic towards the conclusions of many scientists. So I'll just bring that up for you. And again, now this is measuring something different. This is sunspot numbers. Sunspot numbers are very closely correlated with total solar irradiance. So this is why they're often used to show the amount of solar activity and the amount of sunlight that we're getting. Again, if you look back over the last 40 years since 1980, very, very obvious decline. I could show you the one from What's Up With That, but believe me, it's going to show you exactly the same thing. So here again, we have a problem in that Willie Soon is putting this information out. It's been picked up by people all over the internet, and it's passed around blogs and all sorts of other things, and people believe it. Now you put this on your website, and you presumably thought that this was a legitimate and authentic piece of information, but just, that's what I mean by tracking things down to their source. If you actually check the source of the information, you can discover where that comes from, and check the information to see if it's accurate, and it's not. So this is why people know, scientists say the sun is not responsible for recent warming, because it's been decreasing at a time when global temperatures have been increasing. Now, you said in the video there's a one-to-one correlation, but clearly the correlation actually is negative. In other words, if there is any correlation at all, it is that as the sun gets cooler, the Arctic gets warmer. Now, that is obviously not the kind of correlation that makes any sense.
I seem to remember that it wasn't a correlation between temperatures and the sun. It was a correlation between CO2. Wasn't it CO2 levels and what the sun has been doing?
There were two things that you showed in that graph, and let me just get it up again, and I'll show you, because there were actually two graphs there.
Right.
You're looking at it now, right?
Yep, I can see it.
Okay. Now I'm just going to have to look at a bigger one so that I can see the scale on it. Now the one on the left is Willie Soon's graph from his 2005 paper showing total solar irradiance against Arctic temperatures. What he's showing there is Arctic temperatures going up since 1960, and fair enough, that's probably what the temperature record shows. I'm not sure. I think it was a record in Reykjavik he was taking or something, but we do know that Arctic temperatures have been rising. But alongside that, or superimposed on that, is a red line. Now that's in the left-hand graph, and the red line is showing total solar irradiance going up. Now, when you talk about trickery and skullduggery in statistics, he is showing an increase in solar irradiance which is not there, in order to make it fit a temperature rise that is there. Now, on the right-hand side, the one you were referring to just now, here we've got carbon dioxide in the red line, and we've got Arctic temperatures in the grey in the background. And again, it looks as though there is no correlation, but there's, I don't know exactly where he's got these figures from. I hope he hasn't manipulated this to the extent that he manipulated the other one. But if we look at carbon dioxide levels in comparison to global temperatures, because when we talk about global warming, we are talking about global warming. There might be differences in Reykjavik that may not be impacted by carbon dioxide. There might be some local thing there to do with temperature measurements that I don't know about. I haven't looked into that graph, but what I'm saying is you can't take these things at face value.
Since we had that discussion, I've checked the right-hand graph, and I can't see any problem with the Reykjavik temperature data or the CO2 data used. I think the problem was mine. I was probably misreading the timescale of the graph. If you look at the period of warming since 1975, it in fact correlates very well with the steep rise in CO2, whereas of course there's no correlation at all between warming Reykjavik and a cooling sun, the complete opposite of what Willie Soon was claiming. I also checked this against the world temperature versus CO2 graphs of the same time period, and it matches pretty well. This graph is from the Stanford Solar Center. CO2 concentration is the blue line, which correlates well with the red line of global temperature, except for the period from around 1941 to 1975, when we had heavy aerosol pollution. The orange line, which is solar irradiance, only shows a correlation up to the late 1940s.
You have to look into it. The first time I saw Willie Soon's graph on your video, yeah, I was impressed with it. I thought, wow, yeah, that does look as though it correlates. But as soon as I saw that that was total solar irradiance, I thought, no, there's something fishy going on there, because no one in the scientific community, even the measurements that are being taken directly of the sun, show that there's any kind of an increase.
So I do have one question here, which is that, and again, this is more from the economics point of view, but one of the things that you're always taught to do when you're looking at things economically is not to look for a single. It's seldom the case that there's a single cause for any given historical phenomenon, and then to be skeptical of people who look for single causes. So could it not be, I mean, I'm just playing devil's advocate here a bit, could it not be that both the sun and CO2 play a role here, and that it could be, some of one, half a dozen of the other? Why would it not be that?
Oh, okay, but the thing is, there are three main drivers of climate, and I'm talking about active drivers of climate. It's actually a rather complicated thing once you get into the passive drivers, but the active drivers of climate are the sun, carbon dioxide, and aerosols. And as a geologist, I mean, looking back over 500 million years, these are the things that have basically set the global temperature. And they're no different today than they were then. And whenever people talk about, humans are causing this, I say, no, humans are not causing it. Humans have been on this planet for 150,000 years, and we haven't disrupted the climate. It's carbon dioxide. And once you understand it's not humans, it's carbon dioxide that does it, then everything else falls into place, because you can see the correlation throughout geological history. So yeah, the sun and carbon dioxide together are the influences. Now, in the short term, we're talking about decades and perhaps 100, 200 years, which may sound long term, but it's actually, let's say, medium term, because in geological time, that's the blink of an eye. The sun, since it has been declining in solar power, in solar output, or TSI, total solar irradiance, whatever measure you want to make of it, would actually have a cooling effect. Now, I don't think anybody would deny it. I hear a lot of critics, the so-called skeptics, who say, it's the sun, stupid, the sun controls the climate. Well, if the sun controls the climate, how come the climate hasn't been cooling for the last 40 years when solar activity has been going down? In fact, the sun is having a downward impact on temperatures. It's called a forcing, and it's like a tug of war. It doesn't mean that the Earth is getting cooler, but clearly it's not, unless you want to argue about that, but clearly the Earth is warming up. But if the sun is getting cooler and trying to depress global temperatures, as it has been for the last 40 years, something else must be pushing them up. Now, that's not the reason why they know it's CO2. I mean, this theory that CO2 affects global temperature has been around since 1896. It's not new, it's not the least bit controversial in the scientific community. So that's not the reason they know, but it just is so consistent with the theory, and that's what scientists always look for, is consistency. That if these are the three main drivers of climate, then there should be a consistency of when they are in this tug of war, one against the other, that the temperature should be responding to that tug of war. And it is. Now, when you talk about economics, they still create these bubbles. We have an amazing capacity for doing things that are totally illogical. But the wonderful thing about physics is, yes, you can have one thing that has such an effect. And the Earth is a very simple system when you look at things like energy in, energy out, because energy and temperature are directly correlated and directly related in a very simple equation. And I've seen economic equations that I can't get my head around. I mean, some of these equations in economics, even if they work, are so complicated you need a computer in order to work them. So I think you can't really compare the two. And I do get what you're saying about economics. There are so many variables. It's such a chaotic thing. And climate is very similar to that. It's very chaotic, but global temperature is not. Global temperature is actually fairly simple.
I did want to ask my second question on this, which is that if it's such a clear-cut thing, why do you think that skepticism persists, despite what you present as overwhelming evidence in your videos. And I mean, if this is, why is there still a debate about this? I mean,
well, actually, in the scientific community, there's no debate at all. There hasn't been really a debate about this since the 1970s or 80s, and even before that. I mean, the whole point of the whole idea of CO2 changing temperatures has never been a controversial one. It's always been accepted, and no one ever thought it was anything untoward. You've got papers going back to the 1930s, 1950s, 1960s, all very clearly showing that carbon dioxide is a major driver of climate, so that's not a controversial thing. The question is, why don't the general public accept this? Why don't newspaper proprietors and television commentators and people who are not well versed in science, why don't politicians and lobbyists accept it? I do a lot of conversations with people, because this is a very interesting question for me. I'm always, I don't like to argue a lot with the people who come on my channel and post, although, okay, sometimes I do, and they get very irritating. But I'm more interested in finding out why don't accept this. And then what happens is they give me a statement which is clearly nonsense, which has come off the blogosphere, that I know where they got this stuff from. They just read it, they believe it, they copy it, and they paste it. And to me, that's the opposite of being skeptical. That's why I don't call these critics skeptics. But I then show them that actually this information is wrong, just as I've just shown you with the Willie Soon graph. And I'm showing you the actual measurements of the sun show it's been decreasing instead of increasing. Now, you would have thought that any rational human being seeing that and seeing the evidence and seeing the measurements and even seeing other skeptics who agree with that, other critics who agree, would say, oh, you're right. But they don't. They double down on it, and they insist that they just change the subject, or they run away, they don't come back. It's very rare that I'll get someone saying, oh, thanks for explaining that to me. Now I get it. I didn't realize I had been misled by this blog. They still have this absolute faith that whatever blog they've attached themselves to must be telling them the truth. There's a kind of an echo chamber. And to be honest, I think this has happened since the rise of the internet, because I've been in this the science business for a long time, and I've been reporting on climate change since the 1980s for New Scientist and others, and I don't remember this kind of criticism of the scientific community in such a vehement fashion, and it did happen to a certain extent with the ozone layer, and I remember Paul Harvey criticizing it and Rush Limbaugh criticizing it, but despite the fact they had an audience, there was no echo chamber as there is now. People now seem to be very attached to the blogs that they are convinced.
I think a lot of that stuff could easily be explained through what I'd call confirmation bias and heuristics. The Daniel Kahneman stuff. We can explain a lot of that. But I mean, there are still some questions that persist about this, because whenever I've asked people about this, one of the answers I'll get back is, well, it's a vested interest. They have powerful lobby groups behind them. But if you actually listen to Delingpole and friends, they all present themselves more as victims, as people who have been hounded out and shut down and treated as pariahs, and who have, in many cases, lost prestige or lost jobs or lost money as a result of it, and yet they still persist. Whereas if you look at the incentives on the other side, the people who push these things through their research, they get rewarded with grants, with government funding, with they have, in many cases, these days they have big business behind them, and one of the things that I thought about was, well, why does that happen? And I do wonder if even let's just grant that everything that you're saying is absolutely, as in there's no debate about the science. Can you still understand people who may be skeptical of the political ends being pushed? Because one thing that does come with climate change is an agenda that says, well, basically the only people who can sort this out are the government. The solutions have to be pushed from the top down.
Hang on, sorry, there's too many things we're dealing with here. Let's deal with one.
Sure.
I know, I'm very familiar with these arguments, by the way, and they really astonish me. I wanted to go back to the first one, and I should have been taking notes, and I can't remember now what the first. But let's start with the grants. Now, having grants to do research is basically how scientists do things. It doesn't matter whether you're an oceanographer or a climatologist or a geologist or a geophysicist or whatever field you're in. The reason people get into research is because they are incredibly interested in learning how the world works. I've interviewed hundreds of researchers over the last 30, 40 years, and one thing that they really share is a passion for finding out how things work. And let's face it, that's not just a nerdy thing that interests them, but if they want to get anywhere in life, if they want to win a Nobel Prize, the way you do that in science is by showing something that nobody else has discovered. You don't do it by repeating what everybody else has already done. This is what makes me laugh when people say, oh, they're just sort of towing the line. What they're desperate to do is actually show something different, and getting research grants, it doesn't mean that you then get loads of money to live a fantastic lifestyle. It's actually quite the opposite. The people that go in for research are normally the top of their class. You don't go and get a PhD if you're stupid, and you work in the field of academia, so you know that. These are the brightest and the best who normally get PhDs, go on to universities to teach, and primarily to do the research. That's why they take these positions.
What I'm referring to here is that, some of the stories that you'll hear is that, I don't know, somebody wants to do research on squirrels, okay, I know
what you're going to tell me, and they relate to climate change, and therefore they can get their money.
Exactly.
Okay, there's no surprise about the fact that as climate change becomes a more immediate problem, more research is going to be done on it. I'd like to know any field of science where that has not been the case. When HIV/AIDS came into the fore in the 70s and 80s, there was a huge amount of research went into that, not just in medical research, but in social sciences, a massive amount of research because it was a problem. When we had plate tectonics, now this is my field, when plate tectonics came up, and I did my degree a long time ago, plate tectonics was still basically in the hypothesis stage back then. Once people understood that earthquakes were caused by these moving plates, a huge amount of money was spent on research. But this is done not to line the pockets of researchers. This is done for a very good reason. Because once you understand that earthquakes are caused by plate tectonics, they're not just faults that for some random reason are moving that we can't understand. We now understand the mechanism behind us. Then we need to really investigate this, and through all that research, we now have a much clearer understanding of where earthquakes will strike, when they might strike, and how big they might be. And as a result of that, engineers can then either retrofit buildings, or the building code can be changed in order to make buildings more secure against earthquakes. So, a huge amount of research goes in every time we identify a problem. I'm not sure why that is a mystery, or why that means that the research must be bad. I think what people think is that because these guys, and by the way, squirrels and global warming, I don't know if that's ever a thing, but it's possible. But it doesn't mean that you then fake your results, and you have to say that there's global warming by faking results. That would be the end of a career. So any scientist who has decided to go into the field of research instead of into the very lucrative field of lobbying for companies or working for a corporation in doing commercial research,
lobbying for oil companies,
they would have absolutely no interest in faking results, and even less interest in having that fakery discovered and being stripped of their careers and their reputations. It does happen occasionally, but the thing is, just saying that as a matter of principle, because they're getting grant money, they must be faking their results, is a bit of a stretch. I think I would like to see evidence of someone faking results rather than just insinuation.
I'm going to have to leave it there because this file is getting too...
Okay, that previous video clip was from Potholer, a discussion between Potholer on YouTube and Agent. What was this? Something Agent. I forget. It starts with an A. Another YouTuber, and well, the image I have on here right now is the drought monitor map, the latest drought monitor map for this week. So this is the end of June, and even though we had rain, I think we had 2 episodes of rain, quite a bit of rain. I don't know, maybe an inch of rain over a couple of days. Michigan is still classified as in drought. Let's see, is it moderate drought? I think it's moderate drought. Most of the lower peninsula is moderate drought. And you can see out west it's severe drought. And even into the Dakotas, let's see, Dakotas has severe drought, or North Dakota has severe drought. And let's see, what Utah is severe drought. Western part of Colorado, severe drought. Let's see, what am I missing? Arizona. Oh, of course, Nevada, severe drought. And New Mexico, severe drought. So it looks like, and this is the dry season out west. This is the dry season. So normally they don't get hardly any precipitation during this time of year. So this is a bad drought for the western part of the country, and even for parts of the eastern half of the United States, and even in Michigan. So now, when I don't know how many inches of rainfall we need to get out of our drought in Michigan, but this is going to be an ongoing problem, to put it bluntly. So we're going to have hotter and drier conditions in the West. It's certainly going to be hotter. And then with the heat becomes more, there's more rapid evaporation, more rapid snow melt, more, I guess the atmosphere can hold a lot more water vapor. So, and let me, let's see, what can I say about the previous Potholer? There isn't any debate. There isn't any debate about climate change. There's no debate. Temperatures are going up. Global temperatures have been going up for the last, 40 years? So I can show you those 2 clips that I took out of Potholer's video. And there isn't, global temperature keeps going up. Now, this year the temperature hasn't gone up a lot because there's a La Nina. I mean, so it's going to stay high. Excuse me. It's going to stay high. It may not set a record like an El Nino year. It might not set a record temperature. And by the way, out west, you're getting 100 degree above weather, and then in some cases 110, above 110. In the farming, farmers are having to sell their cattle. They're having to let fields go fallow. The almond growers are actually knocking down almond trees. They can't. Almonds take a lot of water, a huge amount of water for, well, a relatively small amount of nuts, almond nuts. So here's what I'll do. I'll put up those other 2 graphs and explain them. And I'm going to say the same thing. Carbon dioxide's been going up regularly. There's no change in the amount because we're still burning gasoline. We're burning natural gas. We're still burning coal. very little of that has changed, and so it keeps going up. I think it's 415 parts per million. Do I have that correct? 415 parts per million carbon dioxide. So that keeps going up, and then solar activity, as measured by sunspots, is going down slightly, and temperature is going up. So I'll get back to those two clips and go over that again. Okay, this is one of Potholer's graphs. In the middle, the blue line and the blue/purple line, the blue line it turns into a purple line, is the carbon dioxide in the atmosphere. So, and the purple line is direct measurement of carbon dioxide in the atmosphere. And let's see, this goes to, okay, so it's 280, so the carbon dioxide parts per million is on the right axis, y-axis. So it starts at 280 parts per million, and then it goes up to 380 parts per million. But this is looks like it only goes up to 2010 on the right side. Then the red line is temperature. And that's been going up since 1950. It's been going up almost every year since 1950. There was a little decline from 1930s to 1940s. It was a slight decline, but it's been going up. And that the decline in the 40s and the 50s was because of particulate matter in the air, or in the atmosphere, which block the sun. So once you get rid of the particulate matter in the 60s, because of our environmental regulation, then the temperature just starts to go up again. And the bottom, the gold or the yellow gold line is sunspot activity, solar activity. So they say sunspot numbers. So there's been actually solar activity has been going down. So there is no debate anymore. There isn't any debate. I mean, so and the sea levels keep going up. What are the other things? Sea level keep going up. The Arctic ice cap keeps shrinking. The glaciers keep melting and receding. So, there's just the evidence is just overwhelming at this point, and there isn't any debate. And then I can play the clip of Margaret Thatcher in 1989, her speech about climate change, global warming. She warned people. She was the UN speech that she gave, and Margaret Thatcher, I think, was a chemist. I believe. I have to double check on that. I think she was a chemist before she became Prime Minister in England. So, I mean, there's little or no debate. And now I'll show here's what was on the front page news. The out west. The one of the dams in California. I'm trying to think of the name of the dam. It's not Lake Mead, it's not Lake Powell. Oh gosh, I've forgotten the name of the dam. But the water level in the dam is so low that they're going to have to shut off the turbines, the electrical generating turbines, because the water level's too low. I mean, it's at a record low. I think it's since they opened up the the dam and started to generate electricity. It's at a record low. So, and the other one is that the almond farmers are starting to knock down or get rid of their almond trees, because almonds take a huge amount of irrigation, a lot. Okay, well, let me pick up some more clips, and then I'll post those. Okay.
This is the iconic Hoover Dam in all of its glory and wonderment.
It was built as a monument to America's ascendancy, providing power and water in a country hungry for both. Yet this triumph of engineering risks becoming a monument to the global tragedy of environmental change, as the reservoir which powers the Hoover Dam depletes.
We're in the 22nd year of drought in the Colorado River Basin. Lake Mead is at 35% capacity, and that means we have about 25% less ability to produce power.
Nature displays its distress well. The white band is the watermark, vividly showing what the level was and what it has fallen to. This reservoir, which supplies the dam and 25 million people, is now at an all-time low.
We will very likely be declaring shortage for the first time ever in the lower basin for the year 2022.
The electricity for 8 million Americans is produced by the Hoover Dam, this vast site powered by Lake Mead. To protect electrical output, a shortage declaration would reduce the water supply to homes and businesses.
People need to conserve water in every way that they can, in their homes, in their landscape. Don't wash cars, go to a car wash, conserve water.
They are just some of the measures that will be needed to protect the dam and the lake, but there are great challenges ahead for both. Drought and climate change are the major problems here, but this year's super high temperatures mean that evaporation has reached record levels too. Enough water is lost every week from here to fill 15,000 Olympic-sized swimming pools. And water pressure on a depleting supply. The dam provides power to Las Vegas, America's power-guzzling playground. It's the fastest warming city and in the driest state. With an expanding population and rising temperatures, conservation is all. Surprisingly, in terms of water at least, the Strip is not the problem. Almost all of it here is recycled.
Here's some water right here.
Wastage elsewhere is the real issue.
This is water waste. Water waste investigator 7158. I have water coming through a brick wall from the backyard.
Las Vegas is tackling that with round-the-clock
On-site
patrols.
leak. Oh yeah, look at this.
With strict laws now in place to restrict the watering of gardens and grass, there are fines of up to $5,000 for those breaching the rules or failing to tackle leaks. And I guess people would say this isn't a big deal, this is only a little bit of water.
But this is cumulative effect. If you take this whole complex, there's thousands of gallons of water that are going out that main gate there. And this water will go into the storm drain system. It'll evaporate before it even hits the lake. So that's where the waste is from this. This is not recoverable. I have a spray and flow situation.
These patrols are part of Las Vegas's attempt to protect the lake that so much of this city depends on. Water consumption is going down, but the lake is going down faster.
It's sad. Every drop counts, as we say, and that's what I do out here is trying to save as much water as I possibly can.
A century ago, human ingenuity delivered a water solution for America's West. Even greater ingenuity will be needed to ensure this wonder of the past has a place in the future. Emma Murphy, News at 10, Las Vegas.
Tonight we have a very special guest, and he is here for a very serious reason.
Utah Governor Spencer Cox joins us in studio tonight to discuss with Fox 13 meteorologist Allison Krogan how the state is handling the drought, a big task to take on. Allison and Governor.
Absolutely. Thank you so much for joining us here tonight.
It's great to be with you, Allison.
So we're on the green screen right now, looking at the drought monitor here across the region, zooming into Utah right now, and it's not a good situation. We're in the middle of the worst drought that we've ever seen here in Utah.
We are. I've always wanted to do this, but 100% of the state of Utah is in drought right now. And you'll notice the light red area and the dark red area. So that extreme drought is the light red area. 90% of the state is in extreme drought. And then we have exceptional drought, which is the darker red area. This is the worst water year we've had in the history of our state.
Yes, last year was our driest year here in Utah. 2020 was the warmest on record for the globe. It tied for the warmest with 2016. So this is part of a bigger trend. We are warming here in Utah. Utah is one of the top 5 fastest growing states for our warming trend. And so we have risen 3 degrees since 1970. The stats just show, it paints a very dire picture here in Utah. As our leader, arguably the most powerful person in Utah, when you hear this and you know that you can help make change, what do you think?
Well, we're also the fastest growing state in the nation, right? So we have more population growth over the past 10 years than any other state. And so those two things, the warming nature of the climate, the population growth, and then getting less water, that's a recipe for problem, right?
Yeah.
So we have to do better. We have to conserve water better. That's something we can improve on it. So we're asking Utahns, look, the Great Salt Lake is at its 5 inches away from its lowest level ever recorded. Lake Powell at its lowest level ever recorded. And we're really worried about having enough to get through this summer and into next year. So we need people to conserve now. And we need, as a state, to make policy changes to be able to store more water and to conserve more water going forward.
Yes, absolutely. And these climate headlines, the warming trend that we're in right now is unprecedented in millennia. And so this is something that 97% of climate scientists agree that this is extremely likely caused by humans. And with this changing climate, that only worsens our drought, because if you're warmer, you dry out faster, the land dries out faster. And so that leads me into our first viewer question. This one's from Nellie. Nellie wants to know, what is Utah's strategy to work with other states to address climate change?
Yeah, so some announcements today. Representative John Curtis from Utah talked about a climate caucus, a Republican climate caucus that are going to be working on these issues. We meet with other governors. I meet regularly with them. We just had some meetings with the governor of Wyoming talking about some changes to energy, which is a really big deal. So a couple things that need to happen. New energy sources in our state, and we have solar projects, wind projects, we have geothermal projects, the largest in the world geothermal project that's starting right now. Nuclear is an option that we've been talking about, and then carbon capture to reduce the carbon output from the traditional energy sources that we have right now. So those are things that we can all work on, but we also need every person, 3 million Utahns, if they make one decision a day, that's 3 million decisions that can help. Driving less, buying electric vehicles, all of those things that can help with our particulate output.
Absolutely.
And then cutting down on our water usage. Those two things are going to help future generations.
Yes, and you have a farming background, so this next viewer question I have for you. This one came in from Blake, I believe. Yes, Blake. What is being done to conserve Utah's agriculture water use?
Well, so nobody has cut back more than our farmers right now. most of them have cut back at least 30%. On my farm, we're at about 70% that we've reduced our water usage. We have dozens of acres that are not being farmed at all this year because of the drought. So farmers have cut back significantly. We also have technology that is changing the way that we farm. You'll notice those pivot irrigation systems that move themselves. My kids really wish we had those, and we'll get there. They use much less water. They're much more efficient. And there's some new technology happening in agriculture right now. Growing food for cattle, actually growing them indoors under lights takes less land and uses a fraction of the water, about 5% that you would normally use to grow the same amount of food.
Wow. Okay. Quickly, another question that we have for you: why are we letting our population grow without a plan for water?
Well, we do have a plan for water, and that's important. So we work with our water districts on this. They have a 30-year plan that they put out a couple years ago, working on additional water sources and conservation. However, what I believe we need to change is I believe we need to increase the plan for conservation. We had a 25% goal by 2025 to cut usage. I think we need to do much more than that. And so what we're going to be proposing to the legislature are big, bold initiatives to remove unnecessary grasses. So think about park strips. People water the sidewalk next to a Burger King or something. It makes absolutely no sense to have those park strips here. Incentivizing people who want to remove sod and put in xeriscaping, low water usage, giving those types of incentives to change. Those are the things that we need to do, and the legislature is going to get on board to help us.
Okay, well, that wraps up our final question that we had, which was, will there be any incentivizing xeriscaping, localscaping, which is an incredible website and resource here in Utah as well. So
the answer is yes. We're going to get that done. There are some in some localities, but we need this to be a statewide project.
Absolutely. One last pitch for Utahns. How can they get more information?
Well, there are lots of ways to get more information. I'm going to give you more information right now. We have all these websites that you can see. slowtheflow.com is a great one. There are so many other websites to do this. Last thing I want to say is just please be careful with fire. It's so dry out there. Fireworks, put the personal fireworks away, save them for next year. Just be extra careful this year.
It sounds like you're on top of this, and I know that a lot of Utahns are really concerned too. So thank you so much for joining us and taking this seriously.
Thank you, Allison.
Well, it's another sign of how extreme this summer's drought is shaping up to be. The state now forecasting Lake Oroville could hit a record low level not seen in nearly half a century.
CBS 13's Steve Large is live at the reservoir with the extra concern they may be forced to shut down the power plant, Steve, because of the water woes.
Yeah, I'm live on top of the Oroville Dam right now. This is the tallest dam in the entire country. Oroville Lake has a huge water supply for the state of California. Normally, not so much right now. It is a picture showing California's looming drought problem. Houseboats sunken down, surrounded by Lake Oroville's steep banks.
It's sad.
Kim Gunter owns a houseboat on the reservoir and has watched the water level lower each day.
They're projecting by the end of summer there will be no available ramps, no access. They may have to move marinas, all over water.
We received only 20% of the runoff that we would have expected from the snowpack we had this year.
John Yarbrough is deputy director of the State Water Project. He says the drought is so intense this year, the state is forecasting the possibility it will be forced to shut down the Lake Oroville hydroelectric power plant. At full capacity, it can generate enough power to serve 800,000 homes. It's running at 20% capacity now and could be shut down by the end of August.
This would be the first time that we would be stopping it because the lake level is so low.
Lake Oroville's record low, a 645 feet elevation, was hit way back in 1977.
We think it will get around that ballpark. We're looking at possibly down around 640. We don't know exactly.
The California Independent System Operator is already planning for alternate energy sources.
If you look out in the distance, you can see where the lake should be.
Water woes and power problems. One look at Lake Oroville shows the concern ahead for California's summer. So if this power plant is shut down, the state says it would take a while to bring it back online. It wouldn't happen until there was enough rain to bring the lake level back up again.
Hey, so check it out.
Access Vision. Your voice, your community.